Hello students, welcome to the class of Digital Signal Processing, and today we will go ahead with DTFT, the properties of DTFT. We were doing those properties of DTFT. Going ahead, today we will be doing the conjugation property, and then we will go on to the symmetry property, frequency shifting, time, and differentiation and frequency. All those properties we will be doing today. So let's get started. We have already done, just repeating, we have already done DTFS, discrete time Fourier series. We studied about the application of Fourier analysis. Why do we do Fourier analysis? We studied the importance of the complex exponential. Now we are going on ahead with DTFT. The property that we will be discussing today is conjugation, time reversal, frequency differentiation, and symmetry property. Okay. Let's get started with the conjugation first. So for conjugation, what is the meaning of conjugation? Conjugation, first time we heard when we were doing complex numbers in class 12, right? So conjugation, what does that mean? Is that if a signal is having both real and imaginary parts. So this is the real part and this is the imaginary part. When you conjugate the signal, the imaginary part will get reflected along the y-axis or the imaginary axis. That means plus j will become minus j will become plus j. Now, how this conjugation property is applied for Fourier transform, that is the thing we will be seeing here. So, let us see the question. Given x of n is equals to e to the power of j omega naught n, find the dt of x star n and interpret the result. This x star n is basically conjugate of xn. So, we have been given x of n is equal to e to the power of j omega naught n, and you have to find DTFT of x star n, means x conjugate n. So what the property says that if the DTFT of x of n is x of e to the power of j omega, then the DTFT of x star n, that is the conjugate of xn, is going to be x star e to the power of j omega. So this is what is the conjugation property of DTFT. Fine. So let us do this question. The question here is xn is equal to e to the power of j omega naught n. Xn is given to us as e to the power of j omega naught n. Now see the property once again. If you take the conjugate of xn, the DTFT is going to be the conjugate of this one. And this will be e to the power of minus j omega. So this j has to be changed to minus j, and you have to also take the conjugation of the whole thing. Okay. So this, if you take the conjugation of this, x star n is going to be what? E to the power of minus j omega naught n. Now, if you take out the Fourier transform of this, that is DTFT of this one, what are you going to get? N is equals to minus infinity to infinity, e to the power of minus j omega naught n into e to the power of minus j omega n. This is your formula. The formula of DTFT is n is equals to minus infinity to infinity, x of n e to the power of minus j omega n. Okay. So here what we are doing is the signal was given to us as e to the power of j omega naught n. If you take the conjugate of the signal, it becomes e to the power of minus j omega naught n. Now, if you take the DTFT of this is accounts to doing this thing, right? Now, if I do one thing, that is, in order to make this portion, the calculations a bit easier, what I'll do is that I'll take xn is equal to e to the power j omega naught n, and I'll use the property. Also, what I'll do one more thing is that I will be multiplying it with un. If you don't multiply it with un, then in that case, you are going to do it from n equals to minus infinity to infinity, e to the power of j omega naught n into e to the power of minus j omega n. The full thing you will have to do for minus infinity to 0 and infinity to 0. So in order to make it easier, what I have done is multiplying it with e to the power of multiplying it with un. So for this one now, when we are going to do this, this thing is going to change from 0 to infinity. So in the next video, I'll try to do this full thing for the full one. But right now, we just need to concentrate on the property. So let us make it easier. E to the power of j omega naught n un. Now this signal is going to be multiplied basically with e to the power of minus j omega n, and that will make it stable. Otherwise, it was unstable, right? Now, what you will get is e to the power j omega naught minus omega into n, right? And this is going from n is equals to 0 to infinity. So if you see, the first term is 1, but from the second term onwards, it is going to become what? This one will become 1, then it is 2. So you can also write this part as n is equals to 0 to infinity e to the power of minus j omega minus omega naught into n. So this here we can write it as e to the power of minus j omega minus omega naught. So this is your x of ej omega for xn. So for xn, the DTFT was x of e to the power of j omega. This is coming out to be 1 by 1 minus e to the power minus j omega minus omega naught. Now, what are you doing is, you are making it x star n, that is x conjugate n. So this is going to be the DTFT. For this is going to be x star e to the power of minus j omega. So if you see this, what are we going to do is, we will take the conjugate of this full thing. In that case, it is going to become e to the power of j omega plus omega naught. Sorry, omega minus omega naught will be here. But the thing is that this portion, this positive j is becoming, this negative j over here is becoming the positive one. So this is the Fourier transform when you take the conjugation property. The next property is the time reversal property. So for the time reversal property, time reversal, it says that if xn has the DTFT as x of e to the power of j omega, then x of minus n will have the DTFT as x of e to the power of minus j omega. Now the question is the same. Xn equals to 1 to 1 for minus 1, 0, 1. You have to find DTFT of x of minus n. So xn is given to us as 1 to 1. This is your 0 point. This is minus 1 and this is 1. The Fourier transform we already took out in the previous class for this one. Now we can write it directly. This is for minus 1. This is for 0. This is for 1. So the first one will be e to the power of j omega plus 2 plus e to the power of minus j omega. But now you need to find out the Fourier DTFT for x of minus n. So that is going to be what? X of e to the power of minus j omega. So by using the property, you can directly write here. This one will become e to the power minus j omega. This one will become plus 2. This is not having any j, so that is remaining same, and this is going to become again the plus 1 plus e to the power of j omega. So here is the time shifting property. Just you need to change the minus n, you have changed to, so n you have changed to minus n, this side omega to minus omega. And in case of conjugation, both the things had to be changed. Got it? So this was the conjugation property. Then you had the time reversal property. Now next let us do the differentiation in frequency property. Differentiation in frequency. So the next thing is differentiation in frequency. The question given here is, the xn is a to the power of n un. You have to find out n into an, n into a to the power of n un using the frequency differentiation property. So first of all, what is the frequency differentiation property? So it says that if of x of n, the DTFT of this is x of ej omega, then the DTFT, if you multiply this xn with n into xn, that means you are doing differentiation in the frequency. So how will it, you are multiplying by n in the time domain. So in the frequency domain, you are going to do the differentiation. That is going to be j into d of d omega, d by d omega of what? X of e to the power of j omega. So for this particular thing, you have xn a to the power of n un. We have already studied in the previous class how to find out the DTFT for a to the power of n un. You can go through the previous lecture, but still if you have not gone, first write down the formula, that is n equals to minus infinity to infinity a to the power of n un e to the power minus j omega n. Since it is un, the limits will change. N equals to 0 to infinity a to the power n e to the power minus j omega n. Now we will club same thing as we were doing in the Z transform also, just the formula is a bit different. Here it was Z to the power minus n, here it is e to the power minus j omega n. The whole thing is to the power of n. Using the geometric series, you will get 1 by 1 minus a to the power of, sorry, a into e to the power of minus j omega. Now, since you need to find out n into xn, the DTFT of this one, n into xn, the DTFT of this one is given as j into d by d omega of what? X of e j omega. So this one is for us x of e j omega. This one is given to us as x of e to the power of j omega. What we need to do is, we will do the differentiation. So it is j into 1 by 1 minus a to the power, a into e to the power minus j omega by d omega. So what will be the differentiation? Let's do the differentiation in this case. This is j, take it out. 1 by a e minus j omega multiplied with 0 minus 1. Now, if you do the differentiation of this part, it's going to be minus what? J e to the power of minus j omega. The whole thing will be divided by, the whole thing is going to be divided by 1 by a e to the power minus j omega whole square. Just by the division. So this part here, this part is going to be 0. Okay. Now this part is j. Here you see minus into minus plus. This is plus aj. If there is a minus over here, let me quickly see this part. So here you see, you have already taken the minus here. That is due to the differentiation property. So minus a, you have taken it out. Okay, so it's fine. Now this is also minus e to the power of minus j omega. So j minus will be there, a e to the power of minus j omega by 1 minus a e minus j omega whole square. Now there was a j outside also. So this one will become j square. J square is minus 1. So minus into minus will become plus. So it is becoming a e to the power minus j omega divided by 1 minus a e to the power minus j omega whole square. So this is from the differentiation property. So differentiation in frequency property says this thing. Now the symmetry property. Now symmetry property is a bit longer, but we will be doing it in short because the thing is that we are doing DTFT. In DFT again, we will be doing those properties in, although the property is a bit different for DFT case, but we need to do all the things complete for DFT. Okay. Now first thing is that regarding the symmetry property. of DTFT. The first property says that X star n. What was X star n? Conjugate, right? If you take the DTFT of this, it is going to become what? X star e to the power of minus j omega. Okay. The next is the X star minus n. Now this is going to become X star e to the power of j omega. Next is real part of this xn. That is going to become even part of x of e j omega. The odd part or the imaginary part, not or, the imaginary, this is the real part. The imaginary part, if you take, in that case, the imaginary part of x of I n, if you take the Fourier transform of that, it is the odd of e to the power of j omega. Okay. After that, you have x of, if you take the even part of xn, then you will have real part in the case of frequency transform or DTFT size. If you take the odd part, then you are going to have imaginary part in the DTFT case. So this is all about the symmetry property. What is, in short, you can say that if you take the real part, if there is a signal, say xn, you can have three cases. The cases here is given as conjugate. Okay. One is conjugate, one is time real part, one is imaginary part, even part, odd part. So a signal can be constituted as real part and imaginary part, a complex signal. Or it can be written as even part and odd part. Now, if you take only the even part of the signal and do its Fourier transform, what you will get in the DTFT will be the only the real part of the full Fourier transform of the signal. Same case of a same analogous case will happen with if you take only the odd part of the signal and do the Fourier transform, then what you are going to get is just the imaginary part of the full Fourier transform of that signal. And the reverse happen. If you take the real part of the signal, you will get the even part of the Fourier transform. If you take the imaginary part of the signal, you will get the odd part. And in case of conjugation, what is happening is, if you take the conjugation of the signal, you are going to get the conjugate of the signal even in the Fourier transform portion. Now, here you can see one important thing that when you are taking x star n, it is x star e to the power of minus j omega. So first, this plus j omega will be changing to minus, and then the full thing again you will take conjugate. And in this case, since it was minus n, this omega was changed to whatever it was plus or minus, it will change to the opposite of that, and then again you will take the conjugate. So this is all about the symmetry property. Now let us do this question, which says that if xn be real and even, prove that x of e to the power of j omega is real and even. All this property I'll do once more because so that you can understand some more questions with this property that will help you. So here only one question is given, xn be real and even. The question given here is that xn is real and even. Now we have to prove that x of e of j omega is also real and even. You need to prove that x of e to the power j omega will be real and even. So see, first of all, xn can be written as two things, xrn plus j xin, or you can write this as x even part of n plus x odd part of n. Now, if you see this xrn and take the DTFT of this part, just now we studied it, right? If you take the DTFT of this part, then what will it become? X e to the power of j omega. And if you take the even part, here if you take the even part and take the DTFT of this portion, then what it is going to become is x r e to the power j omega. So if you combine these two, it is real and even only. So this is the thing that they are asking you to prove it. And then again, you have to verify it for a signal. So verification can easily be done. What we are going to do is the proving part. Fine. So first of all, let us see that x of e to the power of j omega, x of e to the power of j omega can be written as, the formula I am writing, nothing else, xn e to the power of minus j omega n. Now this can be written as what? xn cos omega n minus xn sin omega n. Fine. Now this full thing is for the summation from n equals to minus infinity to infinity only. Got it? Now this part, you know that this part is both the real part and the imaginary part. Here you can say it is real part of e to the power j omega plus j into xi e to the power j omega. So if you equate this one with this one, then what is going to happen is x r e to the power of j omega is x n into cos omega n. So cos, you know, it is an even function. So this whole thing is going to be real and even. So you can take it in this manner. Got it? You know that cos omega n, if you take cos of minus theta, it is going to be cos theta itself. So this part is the real and even part. Now you can easily do it for this signal also. This signal is even, given signal is even. Minus 1, 0, no, it's not even. So first you need to take out the x of e j omega for this one. And then you take out the even part of this signal, real part of this signal, and then do the Fourier transform of that just real part. So let us see this one also once more. X then equals to 1, 2, 1. X of n equals 1, 2, and 1. Here you have 0 at this point. So the signal, if you draw it, it is somewhat like this. This point is 2, point is 1, this is 1. So what you see over here is the signal is even, right? As you know now, for this even signal, the x of e j omega will be real. Now let us just check it. If you do the x of e j omega, we have actually already done it. So it has come out to be what? E to the power j omega plus 2 plus e to the power minus j omega. Now if you take e to the power minus j omega for this, what will you get? Minus j omega plus 2 plus e to the power j omega. So basically what you are getting is x of e j omega is equal to x of e to the power of minus j omega. So this signal is even. So for real part, if you change plus j to minus j, then again the same thing is going to happen. So this signal is both real and even. So this proves us the property of real and even. We will do some more questions with regarding to this symmetry property. But as a matter of fact, the symmetry property, if they ask you to write a symmetry property, that is the most probable question that can come, not to prove the property or questions on the property. Questions on the property can come from frequency differentiation property, conjugation, time reversal, all these frequency shifting and time shifting property. So in the next class, we will be doing convolution in time, convolution in frequency, correlation and modulation theorem. So that will be all for DTFT. So let us meet in the next class and complete this part. Thank you, everyone.